The chip the United States export controls were built to stop Nvidia's H100, the A100, anything with serious artificial intelligence compute, is banned from China. And yet the chip that may pose the deeper long-term threat to Nvidia isn't on any restricted list. It's sitting inside Chinese gaming PCs right now. It plays games. It also runs artificial intelligence workloads. And according to reported positioning, it is the only Chinese chip attempting to do both on a single unified architecture. Before you file this under gaming market rivalry, that's not the argument. Revenue from selling chips to gamers is not what makes this interesting. The mechanism runs deeper, and it's a mechanism Nvidia itself invented. Nvidia has been built into one of the most valuable companies on Earth. That valuation wasn't built on artificial intelligence alone. It was built on a model where gaming and artificial intelligence are not separate businesses. They are the same flywheel. A flywheel in a factory is heavy, slow to start, but once it's spinning, it takes almost no energy to keep going, and enormous force to stop. Whoever learns to spin that flywheel inside China doesn't just compete in one market. They compete in all of them. By the end of this, you'll understand what the flywheel actually is, why the export controls may have left the most important piece unchecked, and what more threads would have to do, and still cannot, to actually threaten Nvidia's position. This isn't a story about one chip benchmark. It's about which architecture gets to compound. And compounding, once it starts, is very hard to stop. So what actually built Nvidia? The obvious answer is artificial intelligence. The real answer is games. In 2006, Nvidia launched CUDA, a general-purpose parallel computing platform built on top of graphics processing hardware that was already being sold to gamers. Nobody built it for artificial intelligence. It was built to help developers push more pixels. Then, roughly a decade later, artificial intelligence researchers discovered that the same parallel architecture that rendered game worlds was extraordinarily good at the matrix math that powers machine learning. Nvidia was already a decade deep into the software stack. The flywheel was already spinning. Gaming revenue funded the research and development. The research and development built CUDA. CUDA attracted developers. Developers wrote libraries, optimized kernels, and built frameworks. An enormous body of tooling that took approximately 18 years to accumulate. That tooling locked in the ecosystem. The ecosystem funded the next generation of hardware. And that hardware won artificial intelligence. You might ask, couldn't a competitor just build a better chip and win? Advanced Micro Devices tried for years. The chip was competitive. The flywheel wasn't. Developers stayed on CUDA because leaving meant rewriting years of optimized code across thousands of projects. The software moat turned out to be deeper than the hardware moat. That's the lesson. Not that Nvidia made great chips, that Nvidia made a platform that kept paying for itself. So what does it take to spin your own flywheel? You need one thing above everything else: a general-purpose architecture that serves both markets at once. That's what makes a chip full function, and why building one is harder than it looks. A dedicated artificial intelligence accelerator is optimized for one type of computation: matrix math, at scale, as fast as possible. Think of it like a purpose-built racing car, incredibly fast in a straight line, useless anywhere else. A gaming chip has to handle real-time graphics, physics, shading, and general-purpose compute on the same silicon, all switching rapidly between tasks. That's more like a high-performance road car that also happens to lap a track well, harder to engineer. But you can use it everywhere. And everywhere is where the flywheel starts. More Threads, a company reportedly founded around 2020, positions itself as the only Chinese chip producer pursuing this full unified graphics plus compute architecture. The dedicated Chinese artificial intelligence accelerators, purpose-built chips from companies like Cambricon, Byron, and Huawei's Ascend line are extraordinarily capable at artificial intelligence matrix workloads. But that's all they do. They have no gaming market. They have no consumer flywheel. They are racing cars with no road to drive on outside the track. More Threads, if the reported positioning holds, is attempting something categorically different. A chip that runs games and runs artificial intelligence on the same architecture, the same way Nvidia does. That's the right shape of attempt. Whether the attempt succeeds is a different question. Here's where the export controls enter the picture, and where the structural blind spot appears. The controls were calibrated to compute performance thresholds, total processing performance and memory bandwidth, that flag high-end artificial intelligence accelerators. A gaming chip, even a powerful one, often falls below those thresholds or sits in a different product classification. It serves a consumer market. Millions of ordinary people buy gaming chips. Restricting them creates enormous diplomatic and commercial friction that restricting data center accelerators does not. So the gaming chip category was treated as lower stakes, a consumer product rather than a strategic asset. The controls built a dam across the river everyone was watching. More Threads is the stream running through the field next door. Could the controls be updated to include gaming chips? Possibly, but regulatory responses take time. And by the time the policy catches up, the flywheel may already be turning. That asymmetry between how fast a company can grow inside an open consumer market and how fast governments can rewrite export classifications is the structural issue. Not that the controls were wrong, but that the obvious threat and the compounding threat are not the same object. Now here's the real question. Is the flywheel actually turning? Or is this still a theoretical architecture doing theoretical things? More Threads has reportedly developed a software compatibility layer, a translation layer intended to allow some code written for Nvidia hardware to run on More Threads chips instead. That is exactly the right strategic move. It is the move that reduces the switching cost for developers. It is the move that, if it matures, could start pulling people off Nvidia's ecosystem the way Nvidia once pulled people onto it. But here's the distinction that matters. Compatibility means you can run the code. Equivalence means it runs as fast. Those are genuinely different things. A translation layer is like a dictionary. It gets you to meaning, but it won't make you a native speaker. CUDA is not a dictionary. It is 18 years of accumulated idiom, optimized libraries, tuned frameworks, and developer muscle memory. Compatibility with CUDA is not the same as having CUDA. And here is the honest accounting. Independent performance benchmarks for More Threads on real artificial intelligence workloads compared to Nvidia hardware or even other Chinese accelerators are not publicly available in confirmed form. Company claims exist. Independent verification is limited. What can be said with confidence is that the architecture allows the attempt, a chip that can run games and artificial intelligence on the same silicon, in a market the controls left open. That is different from every other Chinese chip company. It is not the same as matching Nvidia. More Threads is reportedly founded around 2020. CUDA launched in 2006. The software ecosystem gap is not a minor technical detail. It is the dominant obstacle. The architecture is the right shape. The stack behind it is not yet close. Those are both true at the same time. Here's my honest read. The triumphalist version China has already built its Nvidia is wrong. The software gap alone makes that false. But the dismissive version, a gaming chip is not a strategic threat, this is just consumer electronics, misses the mechanism entirely. The chip is not the threat. The flywheel it is attempting to spin is. And Nvidia's own history is the evidence. The company that built the world's most valuable artificial intelligence platform did it by selling games first. If more threads gets the software layer deep enough, the gaming market does the rest. That's not guaranteed. It's not even probable on a short timeline. But it is the right kind of threat to take seriously, because it compounds quietly. Inside the market, the controls treated as low stakes. The export controls stopped the obvious chips. They may not have stopped the flywheel. And a flywheel, once spinning, doesn't need permission to keep going. Here's the question I want your honest take on, and I mean this genuinely. Does the software gap make this threat manageable for Nvidia? Is 18 years of CUDA depth simply insurmountable on any reasonable timeline? Or does the export control blind spot matter more because it lets more threads grow inside the one market where the flywheel starts? Those are two genuinely defensible positions, and they lead to very different conclusions about how worried Nvidia should actually be. Tell me what you think in the comments. If you want to follow whether that flywheel actually starts turning, the software benchmarks, the developer adoption, the policy response, this channel will track it as it happens. The chip sitting in a Chinese gaming rig right now is not the fastest chip in the world, but it might be trying to do something more important than be fast.